times height times length.
No.
Base times length times height.
No. Hey, look, I'm actually live. Awesome. Sorry that it took so long. How do we find the volume of a right solid?
The whole
Area of base.
Yes, area of base times height. Length times width times height only works if you have a rectangular prism or a cube. Area of the base times the height will always work for. Okay, so what's the area of the base here? It is. Well, okay, what's the height, first of all?
is 11
11 what?
meters.
Thank you. Okay, what's the area of the base?
22.
No.
No.
What's the area of the base? What kind of a thing is the base?
The area of the base is.
What kind of a thing is a base? Let's answer one question at a time.
It's a shape. It's like a trapezoid.
Thank you, it's a trapezoid. What's the formula for the area of a trapezoid?
Like base times height.
Bro, base 1 plus base 2 times height divided by.
That's what I meant. I just said that.
We are never going to use the formula length times width times height in this class.
Yeah.
It's just not a very useful formula. All right, so what are the two bases of this trapezoid?
22 and 10.
How can you tell that those are the bases?
Those are the two parallel.
They're parallel. 22 and 10 are two bases. So what's the height then? Is 24. All right, so let's do the arithmetic. What do we get?
32 times 24.
32 times
12.
over 2, or we could do 32 times 12.
Yeah.
Yeah. Or we could do 16 times 24. Whatever. 32 times 12.
384.
Is that right?
I don't know. I tried to do it in my head.
Yeah. So what I like to do with these is I like to move things around. So instead of 32 times 12, I like to do 64 times 6.
Where do we get 32 from?
22 plus 10. Base 1 plus base 2. Base 1 is 22, base 2 is 10.
You
How
add
does
this.
he got us here?
10 is 32. So I like to do, when I get to something like this, 32 times 12, because I hate multiplying two or more digit numbers together, I'm going to cut one in half and double the other one. So 64 times 6. Okay. Yes, you were right. It's 384. 384 what?
Meters. Square meters.
Square meters. Okay, so what's the volume? 384 times
11.
11. What's 384 times 11?
3,600. No, 3,700 and
4,000.
Yeah. So
4,224.
multiplying things by 11 is not very difficult because cubic meters there, right? Because it's volume. Multiplying things by 11. Notice if we multiply by 11, we've got 384 times 11. So 384 times 1, and then we move over a place, we've got 384 again. So you could just skip to that, where you're writing the two of them off by one place. And then you just add 4, 12, 12, 4. There you go. 42,024 cubic meters.
4,000.
Questions about that one? You need to know these formulas. If you do not know any of the formulas,
What is it? 27.
you just need to learn them.
quick rock me into this drill.
27, the answer was
It's not a drill, but you know it's gonna be a plan.
No, that is not.
26.
Are we gonna run through 4 players?
No.
Any others you want to go over?
No.
You said tomorrow we're out of.
Last call to review.
So, like, what is it?
Is there a place?
Are you guys going to pay
You
attention?
guys didn't? Huh? What is that?
I already told you, but as I was looking for the... I'm in the middle of talking to you. I'm in the middle of reprimanding you for asking me a question, and then while I'm looking to get you the answer, starting a conversation with your neighbor. And then as I'm reprimanding you for that, you do it again. That's really frustrating to me. Please don't do that. If you are talking to me, if you're engaging in a conversation with me, let's keep that line of communication open and don't suddenly break it off to talk to somebody else. Especially since I'm the one you should be paying attention in this room. All right, it's all about me. But please, let's have one conversation at a time. Last call for any problems from 56 that you want to go over?
No, sir.
27.
Number 27, okay.
Having a bad one.
I don't know if I got that.
Wait, did we skip? I thought we were to the bathroom.
Yeah, we skipped 27.
Yeah. Asterisk.
Yeah. All right.
I'm gonna walk out.
No, I made a mistake. Wait, no, we did. Oh, yeah, we did.
We did. All right. So lesson 57, page 232. That's not gum, is it?
No, these are.
Oh, awesome. Perfect.
Oh, yeah, you might have to.
Wait, what's wrong? You're going back.
Hurry up.
Don't give me one.
I said
Please
pencil
listen.
in
You're
your
getting
hand.
early enough to go before
I
class.
said it. You know what? Understandable.
I'm about to teach this lesson.
Are you? I'll give it to you.
Thank you. I shouldn't need to wait for you. It's like what they say, trains don't wait for people, people wait for trains.
Bro, what is wrong with you?
All right. So, adding algebraic expressions with negative exponents. This is actually really not that difficult. So when we have something like this, so let's just look at example 57.1. There on page 233. A x to the negative 1 plus y to the negative 1. Now normally we look at these two and what do we say about adding them? Are these like terms?
No.
So we can't add them,
Yeah.
right? However, there is a way, when we have negative exponents involved, there is a way that we can combine them into a single term. Yes?
Take that close to the bottom and then make it like,
Positive.
Right, we're going to rewrite these with only positive exponents. So how can we write ax to the negative 1,
A over X.
a over x? And how can we write y to the negative 1?
Y over 1. Oh, 1 over 1.
1 over y. Now what we're doing is we're adding what?
X and Y together.
No.
AX plus 1 Y.
What?
A-
No, what kind of things are, what kind of things are we now adding together? Fractions. How do we add fractions?
I did common denominator.
We got to get a common denominator. What's our common denominator going to be?
XY.
xy. So what are we going to do to that first fraction to get xy on the bottom?
We get AY.
We got to multiply by y over y, so we get ay over xy. And then to get xy on the bottom of the second fraction,
X.
we multiply the bottom by x, we multiply the top by x.
Wait, what? You lost.
Okay, so we have ax plus a over x plus 1 over y. Yes?
Yeah.
Those are two fractions that we're adding.
We will do
Yes.
Before we can add fractions, we need to make them have the same denominator.
Okay.
So the common denominator we're going to use is xy.
Yes.
All right, now we need to change a over x
Oh, no, I see it.
so that it has, right? So that it has xy on the bottom.
Yeah.
We multiply by y to get there. Y on the bottom. So we
it's
multiply by y on top, right? So we did the same thing over here. We multiplied y by x to get xy.
Yeah.
So we multiply 1 by x. Okay.
Alright.
Now we can write this as a single term. What would that be?
AY plus X
X all
over XY.
Yes. That's it. Not very complicated. Let's do one more example. Let's do example 3 on the same page, 37.3. But this is not really anything new. So we're going to rewrite, we're going to add with all positive exponents a to the negative 2x, y to the negative 1, plus az to the negative 1. Now, keep in mind when you do something like this, if they're like terms, then you can just add them normally. So first let's ask ourselves, are these like terms? No, they're not. I mean, this one has z and this one doesn't. That's an easy way to see it that they're not. This one has y and this one doesn't. So how are we going to add these two together?
A over XY.
X over a squared y
XY.
Oh,
plus
yeah.
a over z.
right. So the first term,
Yeah.
a to the negative 2 moves to the bottom, becomes a squared. X to the first stays on top. Y to the negative 1 moves down, becomes y to the 1. So we had a to the negative 2, x, y to the negative 1 over 1. We move a down. A to the negative 2 down, it becomes a squared.
Okay.
And then we also move y down.
Right.
And it becomes y to the negative 1. I mean, y to the positive 1. Okay. And then here, we move the z down, it becomes z to the positive 1. Okay, now how do we add these?
So common denominator first. So a squared yz
A squared yz, gotta have our least common multiple.
xz over a squared yz
Yes, we had to multiply the first term by z to get there.
plus what else?
How do we get from
Oh,
z?
plus a cubed y.
Yes, because to get from z to a squared yz, we have to multiply by a squared and by y. So we multiply a by a squared, we get a cubed. When we multiply by y, we get a cubed y. Following that? Okay, now let's write them as a single term.
xz plus a cubed by y over a squared yz.
Yes. That's it, we're done. Be careful. Don't be tempted to cancel things out. You might say, oh, there's a z on top and a z on bottom. There's an a on top and a on bottom, a y on top, y on bottom. You might be tempted to cancel those out. Don't. You can't do that. Why can I not cancel out any of the variables here between the
If
commas?
you like bring it up, it'll be like the opposite exponent.
That's not the issue. That's not the issue because that's sort of how normal cancellation works. If we've got a cubed or a squared, we can write that as a cubed times a to the negative 2. When we multiply them, we add the exponents. Right? 3 plus negative 2 gives us 1, or just a. That's how that normally works. But what's the issue here with this particular expression? Xz plus a cubed y over a squared yz. What's connecting the parts of the top of the fraction together? What's connecting these together?
The add sign.
They're being added. The line of the fraction indicates what operation? Division. Can division undo addition?
No.
No. So we can't do that. We could try taking out a common factor from these guys and seeing if we could do some simplification there. But we can't just cancel out this z and this z because this z is connected to this stuff by addition. And division can't undo addition.
So a squared and a cubed.
We can't.
Wait, what are corrections?
Because this is connected to this by addition. Tomorrow, corrections are due.
Wanna do my next?
Yeah, after I finish the lesson.
Not even today.
Sure. Other questions about this
Sir.
lesson?
No, sir.
Okay, this is not anything new. We're just combining two things now. We're combining moving variables between the top and the bottom of a fraction to make things more convenient for us. Usually we're going to try to avoid negative exponents. And then, once we do that, we can then treat them like any other sort of rational algebraic expressions. That is, fractions involving variables. Where we find a common denominator, we change them in form so that they have a common denominator, and then we just add them like fractions normally do. Yep.
You 21 on 56. 91?
Yeah, so let's do that quickly. So going back to page 232, problem set 56, number 21, right at the top of page 232.
Yes, sir.
This is a good one to go over. So 21, they want us to multiply 3 minus x squared. How do we do this?
Look in the
Be careful. What's connecting the 3 and the x inside those parentheses? Subtraction. And the exponent indicates some kind of multiplication of things by themselves. But notice we've got subtraction inside what? Parentheses. So what's being squared here?
3 minus x times 3 minus
Or this whole thing is being squared. We've got 3 minus x times 3 minus x. Yes?
Oh,
That's what's being squared. And then we do
outside.
first, outer, inner, last. So what do we get? First is what?
9.
9.
Outer is?
Negative 3.
Nope.
Negative 3x.
Negative 3x. Inner?
Negative 3x.
Last?
Plus x. 2x.
Nope.
Wait, 1x plus 1x.
No?
-2.
Oh, plus x squared, yeah.
X squared, right. Notice we've got negative x times negative x gives us positive x squared. Okay, now, are we done?
Like 9 minus 6x plus.
Okay, are we done yet? We're gonna hit, we're not.
Add it up. You gotta add it up.
We can't combine any more like terms here. Look at the directions of the problem. What do they tell you?
Multiply, right, the answer in descending order of the variable.
Is this in descending order of the variable?
No, not for this.
Descending order of the variable will be what?
X
X
squared,
squared,
x squared minus 6x
minus 6x
plus 9.
Plus 9, yes. Descending order of the variable means that the power on the variable starts high and then goes down. So x squared, x to the first, x to the 0. There's your answer. So when you have something, when you have exponents and parentheses, remember that the thing inside the parentheses, the whole thing there is getting squared. So we've got 2 copies of that multiplied by each other. So we've got 3 minus x times 3 minus x. Then we can do FOIL, first, outer, inner, last. And then we need to make sure we combine like terms and write in descending order of the variable.
Wait, what about the thing?
What thing?
The thing. The rest of it.
That's it. We can't do anything else. What else could we do?
The part on the other side of the,
What other part of the equal sign?
other part of the equal sign.
Okay, I've got 4 equal signs up there, 3 equal signs up there. I don't know which one you're talking about.
Right above the answer. Right above it. Yes.
Okay, 9 minus 3x plus x squared.
Yeah.
Is the same as 9 minus 6x plus x squared. We combined like terms. That's all that happened there.
What if you run a test and you don't put it in descending order?
That'd be like a minus 1 kind of thing. That'd be like not simplifying. So, wouldn't hurt you that much, but a little bit. It's good getting that habit. Any last questions about 57? Okay, the following problems for 57 tonight can be skipped. Problem set 57. Test corrections tomorrow, please.
Aye, Captain.
Like
Right.
You're gonna skip numbers 2, 3, 9,
330.
14,
Dot, dot, dot.
25, 28, and 30. You get to skip 7 of them.
That's like
Listen, when you're doing these, you can always do the ones that we skip. I'll be glad to give you the answers if you request them for ones that we skip. I probably won't really want to go over them on the board because probably nobody else did them.
We do all we want to get.
No. But especially if, as you're going through with the ones that you skip, you think that's the kind of problem that I don't like or that's hard. If it looks hard to you, you should probably do it.
Really?
Because that's what's going to, unless it's something where it's just hard because it involves writing out a whole lot of stuff.
Mm-hmm.
You know, like these unit conversions, those, if you're skipping those because you don't want to write out all that stuff, not because you're worried about getting it wrong, that's fine. But if it's the kind of thing that you know that you have trouble with, you should probably do it anyway. And then ask for the answer or come talk to me so we can go over your work. Because you want to be focusing on the things that you have difficulty with. That's what's going to actually make you better. It's not working on the things that are easy because you already know how to do those. It's not going to help you really at all. It's working on the things that you find difficult. All right. Thank you very much for watching.
I guess.
See you guys soon.
You got it.
I don't have